Ladies and gentlemen, good afternoon. It's my pleasure to introduce you with this lecture about non-native species in the flora of Icelandic highlands and mountains. So I somehow feel that it is important to start this lecture with a very basic question. The question is, why do we care about non-native species? And I will start with introducing some basic facts about the non-native species. As we can see, of all 1,800 listed species in the US, 49% are endangered because of the introduced species alone or because of the impact combined with other forces, like, for example, pollution or harvest. Another example, this is an account by botanist Joseph D. Hooker that he in 1843 he went to the island of St. Helena, and he wrote that in 1839 and 1843 I in vain searched for forest trees and shrubs that flourished in tens of thousands not a century before my visit, and still existed as individuals 20 years before that date. Of this I saw in some cases no vestige, in other only blasted and lifeless trunks cresting in the cliffs in inaccessible places. What was the cause of this damage? The damage was caused by goats that was introduced in 16th century by first sailors that came to this remote island of St. Helena. Another example, it's Myxobolus cerebralis. It's a parasite of salmonids that was first recorded in North America in 1956 in Pennsylvania. And after having been introduced via infected trout imported from Europe, it has spread widely and have a devastating effect on trout populations throughout the western part of the US. As we can see here, they are infected fish. All these examples are the examples of the effect of non-native species on the local fauna and flora. What do we know about non-native species from research? Well, there are some basic facts that I would like to introduce. Non-native species, first of all, are far more likely to have ecological and socio-economic impacts than those native species that, for various reasons, can undergo range expansions or increase in abundance, and they become weedy. The negative impacts of non-native consumers are usually far greater than those of native consumers. Numerous studies also demonstrated that the role of invasions is huge, and the role is as a driver of species loss as local and regional scale is significant. Scientific evidence also points to non-native species as a major cause of global and animal extinction. Furthermore, non-native species are frequently implicated as a component of sort of a lethal cocktail of stressors on biodiversity. Invasions also disrupt key ecological processes. What is important, these disruptions are often very subtle, and it may take years, even decades, to unfold or for the implications to manifest. Despite the accumulation of this rigorous scientific evidence of the importance to science and society, the invasion science has been a target of criticism from a relatively small but a very focal number of scientists. Now I will try to review the main point of criticism that are commonly raised by opponents. We need also to have in mind that the criticism in science is something very normal, and that also there are scientists that not only criticize the invasion science, there are scientists that disapprove the paradigms of geology, cosmology, biological evolution, history, and even linguistics. Their criticism in science is something very, very normal, and we will now review the main points of criticism. First of all, the critics of invasion science they say that modern invasions are nothing new. They claim that human-assisted invasions are very similar to those that are already known from fossil record, that they have no significant impact and do not merit any recognition or concern. On the other hand, we have a scientific literature that proved that current biological invasions are unique, and well, they can hardly be compared with those invasions that we know from the past. First of all, organisms nowadays are spreading farther, and in much greater numbers than ever before. The other thing is that human-mediated introductions can create a dispersal pathways that are fundamentally distinct from those pathways that were possible for spread events in the past. So for the spread events that were not involving human actions. The human impact facilitates colonization events that are inadequately explained by natural dispersal models. So that's the main difference between the modern invasions and the invasions that we know from the past. Another point that is frequently raised by opponents of invasion science, they often say that impact of non-native species on biodiversity and ecosystems is exaggerated. Whereas global data sets clearly implicate invasion as a major and growing cause of population level and species level extinctions. We also know that the capacity for invasions to alter the ecosystems were proved by numerous experimental research. This is not commentaries that are stressing this importance. This is really basic experimental research that is carried out in field, and the results are like this. Impacts on invasion on plants extinction is frequently masked by the lengthy time lags that are inherent in plant extinctions. Another point is that increased species introductions rise biodiversity. I even met some people here in Iceland that they say that, well, this is nothing bad to have some more plants because we will get more biodiversity, and it's even better to have more biodiversity than less. So increased species introduction, well, add to regional species pools. They can generate new taxa through hybridization. What's the scientific answer for that? Well, when we focus on a species richness counts, this is a misleading approach. Usually the persistence of many species that are recorded in such studies is not recorded over long periods of time. It's not verified in longer periods. Then extinctions may not be an appropriate measure of impact on ecosystem function. We should also have in mind that non-native species can increase the variety of species in a community, but it's an oversimplification to equate this with increased biodiversity, because species richness is just one component of biodiversity. And the surviving populations of native species may shrink at the same time or become restricted to very poor quality marginal habitats. And such unevenness, I think, it hardly contributes to a more diverse community. I have just 2 or 3 left main points of criticism. Another point is that the positive impacts of non-native species are understated, and that they are at least as important as the negative impacts. Well, again, here there are a few papers published in the last decade that showed that non-native species are far more likely to cause substantial ecological and socio-economic damage, and such ecosystem level regime shifts, and they are far more likely to cause this damage than the native species. Many positive impacts that are attributed to non-natives are likely to be transient, whereas the negative impacts are usually more permanent. What is more, they are often irreversible. This is the argument. The point that is, I think, I dare to say it's a bit stupid sometimes. Well, that invasion science is biased and xenophobic. Then, whereas the non-native status of species is highly relevant to assessing its potential environmental impact, and invasion biologists and conservationists today, they all say and they all depict their motivation as a preventing ecological or economic damage. The same did their precursors as a century ago. And we know that such harm is documented, it's well documented. So the stated motivation is highly plausible, and the attempts to impute some baser motives, like for example xenophobia, well, is at least unconvincing, if not tortuous. And one of the last points that are raised by critics of invasion science, that the biogeographic origin of a species has no bearing on its impacts, and the native-non-native dichotomy holds no value to science. I would say that, well, we can't ignore biogeographic origins as a mediator of impact, because when we ignore this, we also ignore the importance of evolutionary context in species interactions. From the studies that were cited here, we know that the more alien an established animal, plant, or microbe is to the recipient community, the greater will be the likelihood that it will have the disruptive effect on the ecosystem. Well, having said that, I would like to introduce the main topic of my lecture today, and it will be I would like to give you some information about the non-native plant species in the highlands and mountains of Iceland. Highland and mountainous environments of Iceland, I define them as areas that are located above 400 meters above sea level, and they account for about 40% of the country's surface. We know that these are the largest wilderness areas in Europe at the moment. They have never been settled permanently by humans. And we also know from the previous research that I published with my colleagues in 2013 that the area is only slightly affected by non-native plant species. And it's actually one of the very few such areas now in Europe. So the problem is why there is such a low number of non-native species in the highlands. I think that there are at least two main factors that are responsible for this low rate of colonization. First of all, it's a low frequency of human-mediated dispersal, what means that humans, until now at least, were not visiting frequently the highland areas, or they were visiting, but in not a huge numbers. And the other thing is that the prevailing climate is challenging for plant growth, with low temperatures, with annual mean temperature below 0 degrees Celsius. There is a long persisting snow cover, and of course shortness of the vegetation period is another disadvantage for the plant growth. It's about 2 months on average in the highland and mountainous areas in Iceland. But we have to remember that these two constraints are changing very rapidly. First of all, because we have climate change. And the second thing is that this low frequency of human-mediated dispersal, well, I'm not sure if it's still true, because here are the data from the Icelandic Tourist Board, and we can see that just during the last decade, the number of tourists visiting Iceland, well, in 2006 it was about 400,000. Last year it was over 1 million, and the Icelandic Tourist Board estimates that every third tourist is visiting highlands during the visit in Iceland. So it's a tremendous amount of people that is coming every year to see how the highlands look like. So what were my main research questions? The first question was very basic. So how many non-native vascular plant species we can find in highland and mountainous environments in Iceland? Second question, I was interested in comparing temporal trends in alien species migration to Iceland and to highland areas, and if there are some differences between the temporal trends and immigration. Then the third question, do human disturbed and undisturbed areas within Icelandic highlands differ in terms of alien species occurrence? So in short, is there a link between the human disturbance and the occurrence of alien species? Then again, next question is spread within highland areas a second step in alien plant colonization? And the last question, can we point out some hotspots in the distribution of the non-native taxa within highlands here in Iceland? Well, the response for the first question, how many species are there? It seems that between 1840 and 2015, we were able to record just 16 non-native species in the whole investigated area. That's nothing when we compare this with over 300 species that are found in the lowlands. 11 species were casuals and 5 species were found to be naturalized. Out of those 16 species recorded in highland areas, I think that these 3 species, so Lupinus nordcatensis, the Shamsat spitosa subspecies beringensis, so Beringspuntur, and Salix alaxensis, well, they have a potential, significant invasive potential, mainly due to environmental matching, because all 3 species are native to northwestern part of North America. So there is a sort of matching and invasive potential due to that. Lupinus nordcatensis, I think it has the highest potential to not only to invade but also to change the environment. So this impact is even bigger. Therefore, well, it can be treated as the most dangerous in a way, because it elevates nitrogen content in the soil. The content of nitrogen in soils here in Iceland is otherwise very low. And, well, this transforms the whole habitat from nutrient poor to nutrient rich. Now I would like to concentrate on some temporal trends. We can see here a graph showing a cumulative number of new taxa, so new species, that were recorded in highland. That's this left axis, and here is the right axis in blue. These are the new taxa in Iceland as a whole. And then we can see that there is a steady increase in the number of non-native taxa that are recorded over the time. But we can also see that the steady increase in the number of non-native taxa started several decades later in the highlands than in the lowlands. In the lowland part of Iceland, it started at the end of 19th century, whereas in highland areas, it was about 1930. And of course, the number of taxa, you can see that this is hardly comparable. We have hundreds here, and here is just 20 new taxa. It's about here, at maximum. Then another comparison in temporal trends. What we can see here is a cumulative number of new records, so new places where the species were found. And we can see that the shape of the curve is quite similar for the Iceland as a whole and for the highlands. And again, we can see this delay. Here is just several decades delay between the vigorous increase in Iceland as a whole and vigorous increase in the highland areas. The shape of this curve here for highland areas is really, well, alarming, because it looks like an exponential increase now at the moment. Then a few words maybe about the human disturbance and non-native plants. So I aim to see if there is a link between the human disturbance and the occurrence of non-native plants within the highland and mountain areas. To do that, I divided the investigated area, as you can see, in 10 by 10 square polygons. And then in each polygon, the presence or absence of the man-made objects, such as huts or small buildings or other infrastructure, was recorded. And also I recorded the presence or absence of alien plant species. And then I performed a chi-square test in order to test the hypothesis that the occurrence of alien plant taxa is independent of the presence of human disturbance. And the results of the test show that this hypothesis is not true. So these two phenomena, so the human disturbance and non-native plants, are not independent. Then again, another thing that has been done during this project was that I tried to record the distance of places where the alien species were found. And I measured the distances from the man-made objects such as huts, shelters, and small buildings. And then we have here distances from roads and tracks for four selected species: Alopeculus pratensis, Deschamsetes pitosa, Lupinus nutcatensis, and Phleum pratense. What we can see here, that at least two species differ significantly from the rest. These are Deschamsetes pitosa, Lupinus nutcatensis. They are able to spread over huge distances here and here. The same here. Lupinus is also spreading very efficiently over long distances, while, for example, the Deschamsetes pitosa is usually confined to some roads and tracks within the highlands. Another question that I asked during the research on non-native plants in highlands was, is the spread within the highlands a second step in alien plant colonization? So basically, I try to answer the question, what is the spatio-temporal pattern of colonization? So if the first lowlands are colonized and then highlands, or maybe first the colonization starts from highlands and go to lowlands, or maybe lowlands and highlands are colonized more or less at the same time. And here we have results for selected species, but I think the general trend is the same. Here we can see that the species is first well established in the lowlands, and then a few decades after, it starts to colonize the highland areas. This is the Alopeculus pratensis, but the same is in case of the Beringspuntur. We have here the introduction, then the spread within lowlands, and the spread within highlands starts shortly after. Here, Lupinus nutcatensis, Alaska lupina. Again, we can see this delay, so it's starting to spread first in the lowland areas and then taking over also within the highland areas. And that's the same situation is here for Phleum pratense. And Alaska vild, more or less the same situation. The question is just about this delay time. For some species is longer, for some species is shorter. And the last question I asked during this short project was, can we point out hotspots in the distribution of non-native taxa? In order to answer this question, I employed an analysis that is called the hotspot analysis. It's based on Getty's ORT G statistic. And maybe now a few words about how the analysis works. It works by comparing each occurrence within the context of neighboring occurrences. And this is done to determine whether a cluster of species observations, so in this analysis it will be called a feature with high values, is statistically significant. So if it's surrounded by other features with high values. And then after analyzing this, the local sum of feature and its neighbors is proportionally compared to the total sum of all features. And as a final result, we receive a z-score, and statistically significant z-score result when the local sum is much different than the expected local sum, what indicates that the difference is too large to be the result of random chance. This method, so the hotspot analysis, was developed and is used mostly by epidemiologists and criminologists in order to find the hotspots, like for example for the disease outbreaks, or well, places which are dangerous, for example within the cities because of the high crime rate or something like that. And here we have a example how this method is used by epidemiologists. And here is the results I received. So we can point out at least several statistically significant clusters, spatial clusters within the highland areas. The first is Mývatn area, Krafla and Námafjall. We can see that this region was pointed out by the analysis as a hotspot with 99% confidence. The same we have here, Vididalur and Vegaskarð. Here the species are also spreading quite heavily. Then Landmannalaugar and Jökulheimar. So these are the well, touristic attractions within the highland areas. And well, also that was a kind of surprise for me to see that, but still that was the result of the analysis, that southern part of Skagafjörður was also pointed out as a hotspot. But this hotspot, well, it's mainly formed by agricultural species that are spreading from well, places with agricultural activity, mostly grasses, and spreading accidentally into the highland areas. And to end with, I would like to discuss a bit about the future of the flora of Icelandic highlands. There are several risk factors that we have to take into account when thinking about the future of the flora of these areas. The first risk factor is that the Arctic wilderness and Arctic wilderness environments, they have become a major touristic attraction during the last few years. And well, we witness now a huge increase in the international visitors to Iceland. This is partially due to this general trend. That means that the influx of propagules that are carried out on the clothing, gear, vehicles, or visitors that are coming to central highlands is very likely higher than ever before, and will probably continue to grow with increasing tourism. Then this increased propagule pressure will certainly contribute to increased secondary invasions by existing non-native species. So the more species that are present in the lowlands will inevitably be transported with a human traffic into the highlands. And it's highly likely that the new non-native species will arrive. Well, we have a number of new non-native species that we are quite sure that were brought by tourists. I will just show you an example from the last year. It's not from the central highlands, it's from a high temperature area, Deildartunguhver. And well, that's the Arabidopsis thaliana. A big population is growing now in this high temperature area. And it was also found by a tourist, Helmut Wittmann from Austria. He found the species, made photographs and collected some specimens, and then he wrote an email to me if I know that Arabidopsis thaliana is occurring in Iceland, and it's quite a big population just close to the tourist path. So probably some people that were visiting this high temperature area, they just brought this on shoes or something like that. And the species is now quite efficiently spreading in this place. Another risk factor for the flora of Icelandic highlands are the plans to improve the road infrastructure. I think that improvements to the road infrastructure will inevitably contribute to increased propagule transfer into the highlands. So, well, this is quite straightforward. I don't think we need to spend much time in elucidating this problem. So, and to end with, I would like to use the opportunity and advertise my last paper that was published in PJ, Non-Native Species in the Vascular Flora of Highlands and Mountains of Iceland. If some of you are interested in maybe some more elaborated discussion about the topic, please refer to this paper. And thank you for your attention.
Takk fyrir, Pavel. Við höfum núna tíma fyrir umræður. Pavel, hann skilur orðið ágætlega íslensku og ef þið eru með einfaldar spurningar, þá megið bera þær fram á íslensku. En ef það orðið eitthvað flóknara, þá betra að þið bera hana fram á ensku. En gefið mig merki.
Thank you for an interesting lecture. My name is Ingimundur. I'm wondering if you would consider similar areas, alpine areas, elsewhere, and if you consider the measures made in the Antarctic in regard of transmitting pollen and such. Do you think that the species that are likely to propagate in alpine areas like in Iceland compared to elsewhere, that you can in some way limit them through the same measures as they do in the Antarctic?
Well, it's difficult to answer this question. Of course, the Antarctic case, it's a bit discussed in the paper. Well, there are some similarities, of course, between the Antarctic and the Icelandic highlands. But if it comes to limitation, well, I think that the Antarctic it's a bit, well, maybe easier to limitate, because still the tourist traffic is confined to just a few places, whereas here, well, tourists, they just can go everywhere, and the number of tourists here is much bigger, and the traffic with the cars and everything it's just incomparable. Well, that would be my answer. I know if it satisfies you.
Unfortunately, no, but I expected so.
Þakka þér fyrir, Pavel. Þetta gaman að hlusta á og fá staðfestingu og ýmsu sem maður hefur verið að velta fyrir sig sjálfur. Svona til að bara gefa fólki einhverja hugmyndum. Ég er orðinn gamall. Fyrir hálfri öld síðan talaði fólk mikið það hvenær kæmi að kæmi svona 100.000 túristar hingað á ári.
Já.
Talan hefur ekki tvöfaldast, hún hefur tífaldast. Bara til með sjáum munin. Og þannig að eftir því sem að fólki fjölgar, þess meiri náttúrulega afgangurinn. Nú eins með lúpínuna, ég held að mönnum sé nú loksinu farið að finnast full mikið af henni, hún veður allt. Á þessum tíma vorum við miklar umræður það hvort það þurfti nokkuð að hafa áhyggjur af lúpínu. Það er svoleiðis gjörbreytt og skógræktarfólk var að planta lúpínu út allt. Nú sjá menn að þess þurfti ekki, hún sá fyrir því sjálf. Nú þarna, nöfnin sem varst með á korti, menn átt að segja alveg á því, staðurinn þarna, Víðidalur og Vegaskarð, það eru á leiðinni milli Möðrudals og Grímsstaða, nær Möðrudal ef ég man rétt, og hæðin þetta 500-600 metrar. En spurningin er svo hvort að þessar nýju tegundir sem hafa borist eru nokkuð nálægt því að haga sér svona eins og lúpínan sem ekki bara invasive, hún sko invasive og aggressive, svo sannarlega, og mjög mikil ástæða til að vera vel á verði og hafa strangar reglur. Það margt fleira sem væri gaman að minnast á, og ég ætla ekki að vera massa meira. Þakka kærlega fyrir.
Kærar þakkir. Well, I just maybe want to comment something about on that. I think that the new species, mostly they are not that aggressive like the lupin. I think the lupin is by far the most aggressive species now. Well, aggressive, invasive species at the moment present in the highlands. But well, of course, like for example, Berringspuntur, that's another one that has in my opinion, this potential to become very invasive. because of this environmental matching I mentioned here during the lecture, and concerning the number of tourists and the visitors. Well, I doubt if it will be possible really to do something about that. So, well, we cannot probably limit the number of tourists visiting, and it will be also very difficult to clean them before they arrive to the highlands. I just cannot imagine how it could be done with vacuum cleaners or something. It could be, well, there were some studies, for example, that were carried out in Antarctica, and they were really cleaning the people with the vacuum cleaners, and then they saw how many propagules, all sorts of things, so the seeds and even parts of roots and all sorts of things were carried out into the Antarctic. So this is probably the same here. But, well, we just need to, well, be vigilant and try to, well, do as much as we can to limit the extent of future invasions. But I think this is inevitable.
Já, þakka þér fyrir erindi, Pavel. Ég heiti Borgþór. Þú tókst þarna dæmi nokkra tegundir sem hafa verið að breiðast út á hálendinu, eins og lúpína, beringspuntur. Þetta eru svona ræktunarplöntur sem hafa verið notað til uppgræðslu. Eru einhverjir dæmi tegundir sem hafa komið með, borist með túristum inn á hálendið, sem þú veist
Nei, ekki ennþá.
Ekki ennþá, þannig að...
Nei.
Já, takk.
Takk fyrir, Pavel. Mér langaði að spyrja, do you think that thermal areas are a possible hotspot for species?
Yes, I agree. There are several premises to think like that. First premise is that they are highly visited because this is a tourist attraction. So it's a hotspot for the tourists, so for the visitors. And the other thing is that the environmental conditions within the thermal areas are different, and we see that even some native species, for example, like some ferns that are occurring in Iceland, just in the thermal areas, they just take advantage of the hot soil. And, well, it enables them to grow. That's, I think, well, it's very straightforward that the thermal areas can be a first place when the new species can arrive and settle down within the highlands. I agree.
Jóhann heiti ég, Pálsson. Annað en eðlilegt að ef loftslag fyrir hlýnandi að mikið af hálendi í Íslandi grófu upp að nýju. Megnið af lægra hálendinu var algrófið landnám og meira að segja þá man ég eftir miklum gróðri bæði upp á Sprengisandi og sérstaklega á Kili sem algjörlega horfið núna, þannig að þessi hrörnun á gróðurfari Íslands hefur haldið áfram alveg fram undir okkar daga. Og svo kannski að geta þess að raunverulega allar þessar plöntur sem eru hérna í íslensku flórunni voru alien species eða bárust hér á landi og gera ekki annað en að auka íslensku flóruna og mynda gróðursamfélög sem að hentuðu jarðvegi og loftlagi Íslands.
Commentary,
Ég spurði hann í byrjun.
All right, thank you, Pavel. I enjoyed your talk, although I really disagree with the beginning comments, of course. I came here very convinced that actually invasion science is well, you might say a bioxenophobic pseudoscience and fashionable nonsense. I'm just as convinced about that as before your talk. That doesn't reduce the value of this work you've done with examining how the flora is changing. But I have some questions, apart from these comments, I have a few questions more about, well, one of the graphs you showed was exactly the very steep increase in the number of naturalized plant species in Iceland, both in the lowlands and the highlands.
We can refer to that.
Yeah, we can refer to that. Now, one of the interesting things about the slope of that line,
this one or that
this one, doesn't matter, that's fine.
But these are different graphs. Yeah. Okay.
Yeah, but the slope of that line is exactly the same slope that you can find in, let's say, the studies of Sachs and his group at Brown University on all the Pacific Islands, and graphs provided by Ken Thompson from the University of Sheffield on the invasion of Britain by non-native flora. But the interesting thing is that with all these communities, you don't seem to see some kind of a saturation of the flora, that species are being driven to extinction or reduced in size by the invaders in some way. It's rather like, any island, whether it be Britain, Iceland, or I don't know, Easter Island, whatever, doesn't really have a saturation point. The number of species in the Pacific since European colonization continues to increase without any extinction rate. Now, on the other hand, when you talk about non-native species, that's a very general term. You might be talking about the Ebola virus, could be speaking about AIDS, or you can talk about cats and dogs and plants.
But
in those islands where extinction has occurred because of non-native species, it's mainly been because of goats, sheep, rabbits, foxes, or domestic cats.
Are they not?
It's not the question.
Species.
It's not the problem with the plants. It's the problem with some of the animals.
Yeah.
So I just wanted you to maybe reflect a bit on that, whether it's proper to put these things in terms of first this scaremongering about invading plants to Iceland, and then to point out some kind of reduction in biodiversity caused by, I don't know, goats and sheep.
Yeah, well, but we don't know what's the real reduction of the biodiversity, for example, within highlands, because no one checked that.
Well, we know that the highlands are very non-biodiverse. There's not very competition among plants in the highlands.
Of course, but
we must be able to agree on that.
Yeah.
Now the question was on this, actually. What's happening in the highlands is what's happening all over the world. It's global warming. If you look at some of the predictions recently, you'll find birch growing up to the highest mountain peaks. Now, which of the 2 points, tourists or global warming, will have a greater impact on the flora in the future?
I think that they are supporting each other, because tourists came with the seeds, and if they were not tourists and no seeds, then the global warming, I think there are two forces that are like supplementing each other. Don't you think so? Because from one side we have a transportation of propagules, and from the other side a climate that is getting milder and facilitates the colonization. Yeah.
But I still don't see the problem.
Yeah. Well, the problem is that.
Thank you very much for your talk, Pavel. The last two questions or interventions have been very interesting, and I have a question for you, but first I'd like to mention that when we're talking about invasive alien species, we are talking about species introduced by man.
Yeah.
We are not talking about natural distribution change and natural dispersion. We're basically talking about effects of humans carrying or introducing new species, plants or animals. So it has been quite interesting to hear those two comments. But regarding the highlands, and in your study, do you see any, or can you determine any difference in the dispersion, whether that's unintentional or intentional introduction in the highlands of those species you mentioned, or is there a difference between the distribution of the species?
I think it's a bit too early to draw some conclusions. But, for example, here when we compare these dispersion here, these two species these two, so this Shamset's Spitosa lupinus, these are the intentional introductions, whereas these two are certainly unintentional into highlands. And then we can, well, they differ a bit, but I think it's too early to draw any conclusions about that.
Já, takk fyrir tíminn hleypur frá okkur.